Okay, hello, good morning everyone. So, I hope you guys had a good weekend. Sana nakapag-relax kayo kahit konti nung weekend. And I know you were already back to ACAD mode because you had your lab sessions yesterday. How was the lab yesterday? I remember I asked your lab instructors to discuss uh, what was it? Error bounds in polynomial interpolation. Any questions regarding that? Or kumusta naman yung nangyaring lab experience niyo? No comment. But you guys can hear me, right? Okay, great. Thank you, Absidy, for the response. Any questions from there? Wala naman. Clear. Thank you, Chris, Justin. Yeah, clear naman daw. So, yeah, that's the idea. Kasi laging remember, interpolation is just one form of approximation, and of course, in any approximative method or in any approximation setting, of course, there would be errors involved, right? But unfortunately, we cannot know exactly what that error what that error would be, lalo na kung hindi natin alam yung exact value. All right? So kaya in practice, we always look for an error bound or an estimate for the error. We want to get to see what is the maximum possible error that will occur in our approximation. Kasi if we know the maximum possible error, we know what the worst case scenario is. So alam natin, halimbawa, yung estimate natin sa error it would be at most say 10 to the minus 3. So ibig sabihin, alam natin in the worst case, yung error niya ay 10 to the minus 3. And that's the reason why we want to compute for the maximum value of the error term. Ano yung posibleng pinakamalaking value ng error term? Kasi that will give us an idea how bad the approximation could become. In contrast, if you will get the minimum of the error term, pag kinuha niyo yung minimum ng error term, ibig sabihin, malalaman nyo ano yung best case scenario, ano yung pinakamaliit na posibleng error. But of course, we are not guaranteed to get that minimum error. So, at saka napaka-conservative niya. So, halimbawa, sinabi ko yung error ay at least 10 to the minus 6. So, ibig sabihin, alam ko na in a best case scenario, ang error ay napakababa, 10 to the minus 6. Pero that will not give me an idea what could really happen. So, kaya mas insightful tingnan yung possible maximum error. So, kaya ang kinukuha natin ay error bound because we want to get what's the worst case scenario. Tapos alam natin, pag kinuha natin yung maximum error, alam natin na the error cannot exceed that value. So lagi siyang hanggang doon lang yung posibleng error, which makes more sense than looking at ano yung pinakamaliit na error na may incur. Because anyway, that doesn't give us any much insight because the error can be beyond that. Okay, so that's why we get the maximum instead of the minimum for the error term. Okay. Now, I hope you guys have a copy of Module 3. That's what we will be going through right now. So this will be covered from the 27th. That was your lab yesterday, pero technically, masisimulan natin siya ngayong 28 until the 1st of October. And the synchronous lab session for this module will be on the 4th, which will also be the tentative deadline for Lab XR 1.2. So you can see the second part of Lab XR 1 at the end of this module. Okay. So tentatively October 4, depende kung matatapos natin yung coverage niya today. But as a reminder, we extended the deadline of Lab XR 1.1. The deadline is tomorrow, right before midnight yata. So kindly double check. So make sure you have submitted your work. If there is some good reason why you will not be able to meet the deadline tomorrow, just let me know, and actually let me and your lab instructor know. You can send me a chat via MS Teams or an email, CC your lab instructor, so we can adjust the deadline for you. Okay, so don't hesitate. We can evaluate whether we can give you an extension or not. So just let us know. Okay. So for this week, ito yung objectives natin. So calculate the Chebyshev and Lejeune polynomials of certain degree. And then we will see later that this Legendre polynomials, the Chebyshev and Legendre polynomials, would give us a nice set of interpolatory polynomials. Along the way, you might be asked to prove some properties regarding the Chebyshev and Legendre polynomials. Probably in the problem set, there would be one problem regarding objective number 2. Kasi sa lab, hindi naman maganda na ipaprove ko pa yung mga properties na hindi naman gagamitan for applications. And then you should also be able to discuss why and how the use of the roots of these polynomials give rise to the best interpolatory polynomial with respect to some degree of some measure of error. And fourth, of course, the usual, use these interpolating polynomials to solve scientific problems. Okay. Sorry, hindi ko na nabura yung insert others dun sa module. Okay. All right, so here we go. Just a bit of a review in your discussions in the lab. So we have seen that the error for the interpolation over the interval AB is given by this expression, right? Where the number C is an element of the interval AB. All right. So if you want to get the exact error for the interpolation for any x in the interval AB, so kung interpolate nyo yung value ng function at the number x over the interval AB using your interpolatory polynomial, then to find the error, you need to compute the n+1 derivative of f, evaluated at some number psi over n+1 factorial times this product, the product of linear factors of the form x minus x sub I. But again, we cannot find the exact error because we don't know what the value of psi is or c is. Okay? Ang alam lang natin kay c, siya ay number sa pagitan ni A and B. I think we use the mean value theorem to establish the existence of the number c. Pero the mean value theorem did not give us what the value of c is. So, ito lang yung estimate natin sa error ng interpolation at the number x. So usually, if we want to get a degree of the error over the interval AB, tinitingnan natin instead yung absolute value niya. Okay? Tapos, mina-maximize natin yun. Okay. X in AB. Then I'll place C here by X. So pag kinuha niyo yung maximum value ng absolute value nitong term na to, this is always greater than or equal to dun sa error. So ibig sabihin, ito yung worst case magnitude ng error over the interval AB. Of course, as in any mathematical or applied mathematics problem, we always want our method to have the minimal error possible. So if we go back to the error term, okay, paano natin mapapababa yung error? So alam na natin na ito yung error. Paano siya bababa? Okay? So we have several options. Number one is you make n large. Okay? So kasi pwede kong mapaliit itong buong expression na to by making n large. Right? Kasi magkakaroon ka lang naman dito ng higher order derivative pero evaluated at a constant. So ibig sabihin, more likely this will remain a constant divided by a very large number. So when n becomes larger, the denominator n+1 factorial becomes larger. Actually, the denominator grows fast. So pag pinalaki pala natin si n, mukhang kaya nating mapaliit ito. Kasi factorials always grow faster than polynomials. Kasi ito ay magiging polynomial of a high degree. Okay? Ito ay degree n+1. Pero remember, big O of n factorial is always larger than big O of n to the k. Or n to the k is a big O of n factorial. Okay? Meaning factorials always bound any polynomial of any degree. So, ibig sabihin, pag pinalaki ko pala si n, kahit lumalaki yung degree nito, mananalo pa rin yung magnitude ng factorial. But that factorial resides in the denominator. So, ibig sabihin, mas lumalaki yung denominator, mas lumiliit yung product. But in succeeding lectures, we will see that increasing the number of points, increasing n. So remember, n plus 1 is the number of points. So if we increase m, that is tantamount to increasing the number of points used in the interpolation. But there are drawbacks to it, as we will see next time. Okay, so yeah, let's abandon that for a moment. Now, if we don't want to increase the number of points, then an alternative approach is to minimize this guy. I-minimize natin itong factor na to. Okay? Now, let's call this omega. So, ito, tawag natin omega of x. So, we want to minimize omega of x. But how do we minimize omega of x? We can minimize omega of x by choosing the exabytes wisely. Okay? Lalo na kung ang interpolation process nyo ay alam niyo yung function f. But the function f is very complicated and you want to replace it by an easier function. But that function approximates the function f well. Or in other cases, if you can choose what the exabytes to use in the interpolation, then we can take advantage of the choice of the exabytes in order to minimize omega. And if omega is minimized, then this entire term will be minimized, keeping n and c unchanged. All right? So yun yung dalawang approaches. Paano mapababa yung error? Palakihin si n o mamili ka ng magagandang exabytes. Or you can also do both. So for this lecture, we will try to see what would be the optimal choice of exabytes. Kung free ka naman to choose what are the interpolatory abscissas, then we can do that and choose them properly so that we will minimize the error. Okay. And in this module, we have two types of interpolatory polynomials. Number one, interpolation via Chebyshev points, or using Legendre or Legendre points. Okay, one of them treats the error in a local fashion. The other one treats it in a global fashion. So let's see which is which. So hopefully for today, we'll finish Chebyshev interpolation. Medyo nako-conscious ako pag pinopronounce yung Chebyshev. The westernized spelling is Chebyshev. Pero yung true Russian ay Chebyshev, yung basa. And I had a Russian professor dati, so ang basa niya Chebyshev. So medyo nagagaya ko minsan. But I'll try to stick to the Western pronunciation, so Chebyshev polynomial. But the Chebyshev polynomials, or the Chebyshev points that can be used in interpolation, treats the error in a more local fashion. So kaya pwede nating i-minimize yung error in the term in a local sense, or in the L infinity sense. So that's why we are greeted by definition 1 here, which defines the L infinity norm of a function. So if you have a continuous function f over the interval AB, then its L infinity norm, denoted by this guy, okay, is the supremum of the magnitude of f for x's over the interval AB. So, kunin nyo lang yung maximum or yung absolute value ni f. Tingnan nyo ano yung maximum over the interval AB. Well, as long as your function f is continuous on the closed interval AB, then by the extreme value theorem you learned from Math 36, it will have a maximum on the closed interval AB. And the nice thing is that that maximum value will be attained among one of the x's over that interval. Kaya well-defined yung L infinity norm ng isang continuous function on a closed interval. Kasi laging may nag-exist na maximum on that interval, and that maximum is attained on a number on that interval. Okay? So for instance, if your function looks like this, okay, and this is AB, then the supremum of AB will be the value here. Kung ano man yung function value dyan, let's say a number c, then yung f of c, siya yung L infinity norm. Ano lang yung pinakamalaking absolute value over the interval AB. So if your function sometimes is negative, okay, halimbawa, halimbawa, ito yung function, okay, tapos bumaba pa siya dyan, okay, so you always look for the maximum absolute value. So say this is 50, this is negative 52. So ang L infinity norm ng function f na to ay positive 52 because you get the maximum of the absolute values. So it's either the magnitude of the highest point or the magnitude of the lowest point. So that's what the L infinity norm is. Okay, I hope that's clear. Kung ano yung L infinity norm. I don't know if you have encountered the L infinity norm before, but that's it is. So in this sense, we want to choose the exabytes so that the L infinity norm of the error will be minimized. So again, going back, so we want the error term, f of psi over n, okay, hold on. N plus 1 derivative ni f evaluated at c over n plus 1 factorial, then omega. Okay, gusto nating i-minimize to. Choose the exabytes so that this is minimized. Okay. So, yung mga exabytes, nasa loob sila ni omega because this is the product of x minus exabytes. But this guy, the first term, is just a constant. So, lalabas lang siya dun sa pagkuha ng L infinity norm kasi you can imagine or you can prove it na kapag ka mayroong constant multiplier yung function, yung mga constant multipliers lumalabas lang dun sa pagtitake ng maximum. Okay. So basically, this would be f of n plus, this would be the n plus 1 derivative of f evaluated at psi over n plus 1 factorial. This is a constant with respect to the exabytes. So natitira na lang ay yung omega dito. Okay. Kasi we are taking the supremum norm or the L infinity norm with respect to x. So, ito yung gusto nating i-minimize. Kasi yung first factor is just a constant. It goes out of the supremum norm. Okay? Okay. Now, the goal. So how do we minimize this? Again, we minimize omega by choosing the exabytes nicely, okay? And actually, we will prove that we can find what are those exabytes that will make this minimal for some fixed value of n. So for that, we'll need, actually, nandito pala yung derivation, okay? For that, we'll go to definition 2, and here we are introduced to a certain type of polynomials called the Chebyshev polynomials. So the domain, these are polynomials defined on the interval -1 to 1. And they are given by T sub n of x. So T sub n is the Chebyshev polynomial of degree n. And it is defined to be cosine of n r cosine of x. And by the looks of it, you will see why the domain is from -1 to 1. Because x's will come inside r cosine, and r cosine is defined only from -1 to 1. So even though they are called polynomials or Chebyshev polynomials, they are only defined on the interval -1 to 1. Okay, so I hope that's clear. And they are defined this way. So easily, if n is equal to 0, okay, so if n is 0, you will just have here cosine of 0. Cosine of 0 is 1. So the degree 0 Chebyshev polynomial is just a constant polynomial 1. If x is equal to 1, then this guy turns out to be cosine of r cosine of x. But cosine and r cos are inverses of each other. So this will just become x. So the degree 1 Chebyshev polynomial is the linear function x. But after that, T sub n doesn't seem to be a polynomial because if you look at it, cosine siya ng nr cosine. So parang hindi naman siya polynomial for n greater than or equal to 2. Okay? But actually, there's a quick recursive trick that will show us indeed these are polynomials. Okay? Now, for that, we will let theta to be equal to r cosine of x. So ibig sabihin, shortcut, yung T sub n, cosine of n theta lang. And then I can compute the degree n plus 1 Chebyshev polynomial. So I'll just replace all n's in this definition by n plus 1. So you get this. And then you multiply the arguments. You get cosine of n theta plus theta. and then you apply your trigonometric identity for the sum for the cosine of a sum. So you will get this. Okay. And then you can redo this process, but do it for t sub n minus 1. Okay? Ginawa niyo siya sa t sub n minus 1, ito yung makukuha niyo. And so, I can add t sub n plus 1 and t sub n minus 1 to get this guy. So the sum is just equal to 2 cosine n theta, cosine theta. Okay? But remember, we let theta be equal to r cosine, so that means cosine of theta is equal to x. So cosine of theta will be x. And then what? Then we'll have the 2 there. But what is cosine of n theta? Do you remember what cosine of n theta is? Oh guys, andyan ba kayo? So remember that cosine of n theta is exactly the nth degree Chebyshev polynomial. Okay. So basically, this is t sub n of x. So here we see that t sub n plus 1 plus t sub n minus 1 of x is equal to 2x times the degree n Chebyshev polynomial. And then if you play around it, we'll get a recursive formula for the degree n plus 1 Chebyshev polynomial. Okay, so I just subtracted t sub n minus 1 from both sides. So that means if you know the last two Chebyshev polynomials, then you can compute the n plus 1 degree Chebyshev polynomial. Remember, we already knew that the first Chebyshev polynomial is 1, the second is x. So to get t sub 2 of x, we'll just get twice of x times t sub 1x, the previous Chebyshev polynomial, minus the Chebyshev polynomial 2 steps before, t sub 0. Okay? But we know that t sub 1 of x is x, and t sub 0 is 1. So the first Chebyshev polynomial, or the degree 2 Chebyshev polynomial, is 2x squared minus 1. And then if you want to see what is t sub 3 of x, the degree 3 Chebyshev polynomial, you'll just do 2x times the previous Chebyshev polynomial times the Chebyshev polynomial 2 steps before. Okay, so this would be 2x times 2x squared minus 1 minus t1, which is just x. So this would be what? 4x cubed minus 2x minus x. So we get 4x cubed minus 3x. Tama ba, guys? And then you see here that the process will go on, and at every iteration, we will get a polynomial. Kasi nangyayari lang naman, you have two previous polynomials, t sub n and t sub n minus 1. Yung t sub n, minumultiply ko lang ng 2x, so I'll get the polynomial back. Polynomial minus polynomial, it will become another polynomial. Tapos alam natin na we notice that t sub n plus 1 is indeed 1 degree higher than t sub n, because here we have degree n, tapos may multiplier na x, so nadagdagan ng isa yung degree niya, naging degree n plus 1 to. Ito ay degree n minus 1, so hindi pwedeng makancel yung x to the n plus 1 dito. So ibig sabihin, indeed, t sub n plus 1 is of degree n plus 1. Okay? And then if you want to play with it, you can compute higher order Chebyshev polynomials, and you'll get the entries in this table. Okay? Yan yung at least the first 8 Chebyshev polynomials. Okay so far? Okay lang ba?
Okay naman po, sir.
Okay, good. So, para saan ba yung Chebyshev polynomials? Well, the promise is, remember our goal? Our goal is to minimize the L infinity norm of omega, yung second factor dun sa error term, by choosing the exabytes correctly. So, ano yung magandang bagay sa Chebyshev polynomials? Well, we can go through first and investigate some of its properties. And those properties are summarized in remark 1. Okay. Ano sila? Well, the first one is the recursion formula that we have generated. So if you don't want to look at it as cosine ng n r cosine of x, so you can compute Chebyshev polynomials using equation 3.2. So that's fine. And I think napahapyawan na natin yung proof by mathematical induction that t sub n is of degree n. And then the thing is, it is not monic when n is greater than 1. Have you guys encountered the term monic before? Or ito ba yung first time? Monic polynomials, yung mga nag-111 siguro na narinig na nila.
First time po sa akin, sir.
First time. So, pag sinabi lang nating monic, hindi 1 yung leading coefficient. So, when we say leading coefficient ng polynomial, yun yung coefficient ng highest degree. So, kung ang polynomial nyo ay, say, p of x equals 3x squared plus 2x minus 1. So, ang leading coefficient niya ay 3, not equal to 1. So, ibig sabihin, hindi siya monic. Pero kapag ka ang leading entry niya or leading coefficient niya ay 1, yun yung tinatawag natin na monic polynomials. For instance, you have x squared plus 3x minus 3,125. So ito ay monic kasi yung highest yung degree niya ay 2, coefficient ng x squared ay 1. So yun yung mga monic polynomial. And I guess it wouldn't be hard to convince you that the Chebyshev polynomials are not monic when n is greater than 1. Kasi si t0 at saka si t1, monic sila. 1 and x, ang leading coefficients nila ay 1. Pero starting from n equals 2, nakita natin dito sa table, leading coefficient 2, leading coefficient 4, 8, 16, 32, and 64. Bakit ganun yung itsura? Kasi remember yung recursive formula? Lagi kang meron 2x times the previous Chebyshev minus t sub n minus 1 of x. Okay? So, ibig sabihin, namumultiply lagi ng 2x yung previous Chebyshev polynomial. So, that means it cannot be monic because it always gets a multiplier a 2, right? Habang nag-iterate ka for the values of n. So, hindi monic kapag ka ang Chebyshev polynomial ay degree 2 or higher. Okay? And actually, we can say more than that. We can say na leading coefficient ng Chebyshev polynomials ay laging what? 2 to the power... 2 to the power what? 2 to the power n minus 1. Tama ba? Ito ay degree 2. So, ibig sabihin, coefficient niya ay 2. Ito ay degree 3. So, ang leading coefficient niya ay 2 to the 3 minus 1. So, that's 2 squared equal to 4. X to the 4th will have coefficient 2 cubed. So, and then imagine x to the 8th. The degree 8 Chebyshev polynomial will have 128 as its leading coefficient, which is 2 to the 7th. Okay. How about 2 to the 7th? Yep, I think so. So I think that's also that could lead to a proof by induction of remark number 3. Okay. Saying na ang leading coefficient niya ay 2 to the n minus 1. Actually, it is even when n is even. And then it is odd. It is an odd function when n is odd. Then ito yung maganda sa kanya. Or actually, these are the highlights of the Chebyshev polynomials. Property 5, meron siyang simple roots over its domain. Tapos ito yung itsura ng roots niya over the domain. Meaning dito nagzi-zero yung Chebyshev polynomials. Okay. And I think it's easier to see these or to prove property 5 by looking at the trigonometric definition of the Chebyshev polynomials. Because remember, ang Chebyshev polynomial ay ang t sub n ay cosine ng n r cosine of x. And then we're looking for the zeros of t sub n. So equate ko lang to sa 0. Right? And then when is cosine of something equal to 0? Nagsi-0 ang cosine kapag Kailan yung nagsizero ang cosine? Nagsizero ang cosine kapag multiple ni pi over 2. Right? Or odd multiple ni pi over 2. So that means n times r cosine of x should be a k pi over 2. K is odd. Okay. And then you can do the calculations, or I can replace k by saying it is 2k minus 1 pi, but this time k is an integer. Para lang mag-guarantee ko na siya kagad ay odd. And then I can divide both sides by n. And then we're looking for x's, right? So I'll take the cosine of both sides. So I get cosine of this guy, and then I'll get the cosine of this guy as well. And then if I do so, this guy will just simplify to x, because the cosine and r cosines are inverses of each other. So that gives us the n roots of the Chebyshev polynomial. So if you have a degree n polynomial, we will have exactly n roots, and those roots will look like this. So hindi pala mahirap hanapin yung roots ng Chebyshev polynomial because they follow this nice formula. And the proof was given to us by looking at the trigonometric identity or the trigonometric definition of Chebyshev polynomials. In contrast to the first four results, which were easily proven by looking at the polynomial definition of a Chebyshev polynomial or its recursive form. So kaya mas madali ito using yung trigonometric. And I think property number 6 can also be easily seen by looking at the Chebyshev polynomials in a trigonometric fashion, because statement 6 looks at the absolute extreme values of the Chebyshev polynomials. So ano yung maximum and minimum value ng Chebyshev polynomial? But again, the Chebyshev polynomials look like this. It is the cosine of some angle. So ibig sabihin, ito ay laging element, yung function value na yan ay element ng negative 1, 1. Kasi cosine nga siya ng some angle. So lagi lang siyang from negative 1 to 1. So the maximum is 1, the minimum is negative 1. And when is this attained? Well, this value or this will attain the maximum at plus or minus 1. Pero kailan nagiging positive or negative 1 ang value ng cosine? That is when the angle is what? Is a multiple of pi. Tama nga ba? So this is when the angle inside cosine is equal to k pi. K is an integer. Okay. And then we divide both sides by n again. I-divide ko by n kasi para makuha ko yung cosine ng both sides. Then I'll take the cosine of both sides para makuha ko si x. Okay. And so this guy will be x. So these are the x's that will give us the maximum value for the Chebyshev polynomials. Actually, the maximum and the minimum values. Okay? Sabi ko pa naman malalagay sa problem set yung isa sa mga proofs ng properties ng Chebyshev, but here I am. Mukhang na-outline ko na yung proof, at least, so you guys can formalize them later. Okay. Any questions so far? I hope clear pa naman siya before we proceed. Okay, now look at remark number 2. We said that the Chebyshev polynomials are not monic, but remark number 3 says the leading coefficient is 2 to the n minus 1. I will be more interested with looking at the scaled Chebyshev polynomials so that they become monic, right? Dahil alam ko na yung leading coefficient, pwede ko na lang siyang i-divide yung Chebyshev polynomial by the leading coefficient to get a monic one, right? And that is what is done here. So I defined a new class of functions. I call it t hat sub n. Yung mga t-hat sub n, sila lamang yung monic version ng Chebyshev polynomials. So the first monic Chebyshev polynomial is still t sub 0, which is equal to x. Okay. Actually, yung t1, t hat sub 1 of x ay equal din kay x kasi monic na siya. But for higher order or higher degree Chebyshev polynomials, para makuha ko yung monic version niya, i-multiply ko yung normal Chebyshev polynomial by 2 to the 1 minus n. And since we know that t sub n will have leading coefficient 2 to the n minus 1, pag minultiply ko yun ng 2 to the 1 minus n, yung leading coefficient magiging 1. But of course, here I am multiplying 2 to the 1 minus n to the entire polynomial. But the point is now I have created a scaled version of the Chebyshev polynomials so that the leading coefficients are equal to 1. Mas interesado akong pag-aralan ano yung itsura ng monic Chebyshev polynomials. Okay. However, this doesn't affect the property or the nice properties of the Chebyshev polynomials that much because kung ano yung roots ng Chebyshev polynomial, siya pa rin yung roots ng monic Chebyshev polynomial, right? Because if x is a root of t hat, okay, or t sub, sorry, not of t hat, but if x is a root of t sub n of x, then we know that t sub n of x is equal to 0. But if I multiply both sides by 2 to the 1 minus n, t sub n of x, 0 pa rin yung sagot. Pero yung left-hand side, remember, this would be t hat sub n of x. So kung ano yung roots ng Chebyshev polynomial, siya pa rin yung roots ng scaled version or yung monic version ng Chebyshev polynomial. What will change as well ay yung, ano ba magbabago? Magbabago lang yung minimum or maximum value. Because remember, the maximum and the minimum value of t sub n are +1 and -1 respectively. Pero yung monic Chebyshev polynomial, yung maximum at minimum value niya, mamumultiply lang ng constant na 2 to the 1 minus n. So ibig sabihin, the maximum value of t hat is 2 to the 1 minus n, and its minimum value is is negative 2 to the 1 minus n. Kasi na-scale lang silang lahat. But the places where those maxima and minima are attained ay yung pa rin, yung mga c sub j's kung saan natin nakuha yung maximum at minimum ng Chebyshev polynomial. Okay? So I hope those basic facts about the Chebyshev polynomials are clear. Before we go to the proof or the main theorem for today. Okay, no questions? Now, what is this fuss about Chebyshev polynomials? Bakit kailangan natin silang pag-aralan? Well, if we go to Theorem 3.1, we see that the monic Chebyshev polynomial attains the minimal L infinity norm. Yun yung sinasabi ng Theorem 3.1. Kasi kung meron ka pang kahit anong monic polynomial of the same degree n, yung L infinity norm ni monic Chebyshev polynomial ay laging mas maliit or equal to the L infinity norm of the monic polynomial of degree n. So ibig sabihin, among the class of all monic polynomials of degree n, yung monic Chebyshev polynomial yung may pinakamaliit na L infinity norm. Pero bakit? Ano ba yung example ng monic polynomial na gusto nating i-consider? So that Theorem 3.1 will make sense for us or will have a significance for us. Anyone? Bakit kaya gusto ko yung Theorem 3.1 ay pag-aralan? Ano yung implication ng Theorem 3.1 sa polynomial interpolation or to our goal which we set up earlier? Sabi natin, ang goal natin mapababa yung error with respect to the L infinity norm. Pero how will Theorem 3.1 help us attain that? Sige, anyone who wants to answer will get +1 sa problem set 1. You can raise your hand. First one to raise hand. Bakit kaya? Ano yung significance sa Theorem 3.1? Okay, you can raise your hand or paunahan sa chat. Come on, guys. Kahit hula. Okay, Absedi, yes. What do you think?
Kasi sir, yung P infinity or sir, nakalimutan ko po yung tawag. Siya po yung parang highest absolute value yung kanina. So kung makakahanap tayo ng value na mas maliit sa kanya, edi parang mas mami-minimize natin yung error na dun sa omega.
Yeah, sorry Absedi, medyo yeah, sorry, medyo lagi yung internet ko. Can you repeat that quickly?
Hello? Okay,
Sorry,
okay na po ba,
choppy yung
sir?
reception.
Edi, type ko na lang po,
Yeah,
sir.
yeah, ayan, mas okay.
Hello. So yun nga po, kanina po, ang gusto po kasi natin is palitin yung error or yung omega x. Tapos yung yung P infinity, siya yung parang highest value. So kung makahanap tayo ng function na magbibigay ng value na mas maliit doon sa P infinity, edi mas mapapalit natin yung error, which is yun yung goal or objective natin from the start.
Yeah. Hello, sorry, Absedi. Yeah, sorry. Kung kailan ka sumasagot, dun pumapangit yung reception ko. Sorry, pero yeah, maybe I can review in the recording what you said. Pero okay ba? Nagpuputol-putol ba ako or yung reception ko lang yung putol-putol? Hopefully hindi ako nagpuputol-putol while nagdi-discuss. Sorry, Absedi, ano ko na lang. I-check ko sa recording. Pero the idea there is hopefully ano, ang idea kasi natin ay i-minimize yung error. Pero ang naging goal natin ay i-minimize na lang si omega for now by choosing the exabytes. Pero remember how omega was defined? Si omega ay product ng x minus xi. So ibig sabihin, pag kinuha ko yung mga product na yan, x minus x1, x minus x2, x minus x3, and so on, ano yung makukuha ko? I will get the polynomial of degree n, or degree n plus 1, right? But it doesn't matter kasi the point here is that this is a monic polynomial. I'll get an x to the n or an x to the n plus 1. So ibig sabihin, kung gusto kong i-minimize yung L infinity norm ni omega, okay, pwede ko na lang tingnan ano yung monic polynomial na may pinakamababang L infinity norm. And that's what Theorem 3.1 tells us na ang monic polynomial na may pinakamaliit na L infinity norm ay yung mga monic Chebyshev polynomials. So if we can choose omega to become the monic Chebyshev polynomial, then we're good. Okay? Yeah, siguro ganun yung sinabi ni Absedi kanina. Pero yeah, that's the idea. Kasi yung gusto nating i-minimize ng L infinity norm ay monic. So let's search for the polynomial that gives us the minimal L infinity norm. So let's see. Let's quickly look at the proof. Okay. So, okay, there we go. So the idea is proof by contradiction ulit. So suppose there exists, so suppose for sake of contradiction, that there exists a polynomial P of degree n, actually a monic polynomial. A monic polynomial of degree n such that its L infinity norm is smaller than the L infinity norm of t hat sub n. Pero alam na natin yung L infinity norm ng t hat, right? That is the supremum of the absolute value. So ito ay 2 to the 1 minus n. Okay? Now, kunwari, merong monic polynomial of degree n na mas maliit yung L infinity norm kesa sa Chebyshev polynomial of degree n. Okay? Tawagin ko siyang P. And I want to find a contradiction, or at least I want to show that P is equal to T hat sub n. Okay? Now, I will define this function. Define the function, say, Q to be E hat sub n of x minus P of x. Okay. So note that Q is of degree n minus 1. Do you agree? Kung ganito ko i-define si Q, ang degree niya ay n minus 1. Bakit siya degree n minus 1? Degree n minus 1 siya kasi si t hat ay monic, so meron tong x to the n. Si p sub x ay x to the n din kasi monic siya, tapos degree n siya. So pag sinubtract ko sila, yung mga leading terms nila ay magka-cancel. So magzi-zero siya, kaya ang degree ni Q, sure ako ay at most n minus 1. Maybe let's qualify that is of degree at most n minus 1. Kaya gusto kong paglaruan yung mga monic kasi sure ako na pag nag-subtract ako ng dalawang monic polynomials, mababawasan yung degree. Okay? Now, let's see. Now we let C sub j be the points where P hat is at maximum. So yung mga CJs, sila yung mga values on the interval negative 1 to 1 kung kailan na-attain ni T hat yung kanyang maximum or minimum value. Though alam na natin siya kanina, dun sa remark 3.1, alam po na siya ay nangyayari dito. Sa cosine j pi over n, j going from 0 to n. Okay? So pagka degree n yung Chebyshev polynomial, it will attain the maximum and its minimum value at plus or minus 1 on n plus 1 points. Okay. So here, maximum, minimum. So note ko lang here, j goes from 0 to n. Okay, now let's look at Q of zj. So ito ay t hat sub n ng cj minus p of zj. Right? Nag-plug in lang ako. And I'll do this for all j starting from 0 to n. So alam ko, itong Chebyshev polynomial, sa mga CJs, it will attain 2 to the 1 minus n times negative 1 to the j. Okay, kasi ang maximum value niya ay naglalaro lang, or yung maximum at minimum niya is either negative 2 to the 1 minus n or positive 2 to the 1 minus n. And then the j determines whether I get a positive 1 or a negative 1 for the cosine. Okay? Kaya siya yung nagde-dictate ano yung sign ng value. Okay? And then minus p of zj. Now, if j is even, then we'll have q of zj ay equal kay 2 to the 1 minus n minus p of zj. Okay. Now, ang anong alam natin about p of cj? We know that p of zj is less than, or actually is less than or equal to 2 to the 1 minus n. Bakit alam natin to? Well, we know that because contradiction nga pala yung proof ko, no? So dapat ito ay less than. Kasi ninegate ko yung conclusion ng theorem. Ang conclusion ng theorem ay Chebyshev less than or equal to L infinity norm ni P. So pag ninegate ko siya, magiging less than. Tapos, ang L infinity norm ni P ay mas maliit kaysa sa 2 to the 1 minus n. Okay. So that means P of Cj is always less than 2 to the 1 minus n. So if this guy is less than 2 to the 1 minus n, so this difference is what? Do you agree this will become positive? Tama, no? Kung si
Apo,
P of
sir.
Cj ay negative, ito ay magiging mas positive kasi negative by negative. Kung ito ay positive, pero yung positive value niya hindi lalampas sa 2 to the 1 minus n, so ibig sabihin ito ay magiging positive. Okay? Now, similarly, if j is odd, yung Q of Cj ay equal pa rin sa, ay magiging equal sa negative 2 to the 1 minus n minus P of Zj. If you do the similar analysis as we did for the first case, you'll be able to show that this is less than 0. Okay? So anong gusto nitong palabasin? For two values of Zj, two consecutive values of Cj, nag-shift siya from being positive to negative. So kung i-drawing natin siya, okay. So alimbawa ito si Z1, dahil add to, negative yung value ni Q. Tapos sa Z2, dahil yung J ay odd, positive yung value niya. Z3, negative yung value niya. Z4, positive yung value niya, and so on. So ang graph ni Q, posibleng ganito yung itsura. Alright? Because Q is a continuous function being the difference of two polynomials. So ibig sabihin, kung meron kang dalawang magkasunod na C sub j's, ibig sabihin negative to positive, ibig sabihin by the intermediate value theorem, kailangan yung graph ni P mag-i-intersect sa x-axis, right? Kasi continuous nga siya, so kailangan dadaan siya sa x-axis. So meron siyang 0 dito. So ito yung unang 0 niya, or unang root. Pero from Z2 to Z3, it will shift from being positive to become negative. And again, Q is continuous. So by the intermediate value theorem, tatama dapat yung graph ni Q sa x-axis ulit. So that gives us the second 0. Okay. So kung meron kang tatlong places kung kailan na-attain niya yung maximum o kaya minimum, meron kang dalawang zeros. And this process will go on. So how many times did we get a maximum or minimum? Remember, we always get a maximum or a minimum from 0 to n. And there would be a total of n plus 1 such incidences. So ibig sabihin, na-attain natin yung maximum at saka yung minimum on n plus 1 points. So kung meron kang n plus 1 points, ibig sabihin dapat n times ka dadaan sa x-axis. Kasi meron kang n plus 1 points at least na positive at saka negative kung saan nagbabago yung sign. So in the transition between them, there should be one moment wherein the graph of Q will intersect the x-axis. So that means kung n plus 1 na beses nag-shift from positive and negative, so that means there should be at least n times wherein dumaan tayo ng x-axis. Pero bawat isang daan mo sa x-axis, that is equivalent to having one root. So here we say that Q has n distinct roots. And this is again a contradiction. A contradiction to the fundamental theorem of algebra. Kasi sabi ng fundamental theorem of algebra, kapag ka meron kang non-zero polynomial na degree n, ibig sabihin hanggang n lamang yung number of distinct roots niya. Pero ano ba ang degree ni Q? Si Q ay degree n minus 1. Pero meron tayong n distinct roots. So that means there is a contradiction. So ibig sabihin, Q must not be a non-zero polynomial. So that means Q must be equal to the 0 polynomial for all x in the interval -1 to 1. Okay? Pero paano na-define si Q? Si Q ay defined to be P minus, Chebyshev, Monique, T hat sub n of x minus P of x, and it should be equal to 0 for all x. So meaning T hat sub n of x must be equal to P of x. So ibig sabihin, kung may mas maliit pa, kung meron ka pang polynomial, monic polynomial ng L infinity norm ay less than or equal to the L infinity norm of the monic Chebyshev polynomials, that means that polynomial should be the monic Chebyshev polynomial. Kasi imposible na siyang bumaba. Okay? All right. I hope the proof makes sense. That's it. Do you have questions? Yan ako kinakabahan sa mga walang tanong or wala man lang reaction. Pero at least, I hope you get the gist of the proof kung bakit ganun and how the process went along. Okay, so yeah. Now, what's the point of showing you this? So as nasabi nga natin kanina, gusto nating i-minimize si omega. And omega is a polynomial, is a monic polynomial. So that means to minimize the L infinity norm of omega, I want omega to become the Chebyshev polynomial. Okay? And if it is a Chebyshev polynomial, so ganito dapat itong omega na to, siya dapat ay maging yung Chebyshev polynomial. And how will it become a Chebyshev polynomial? It will become a Chebyshev polynomial if the exabytes are the roots of the Chebyshev polynomial. Actually, may typo. Yung huling term dapat ay x minus x sub n plus 1. So basically, for omega to have the minimal L infinity norm, omega must be the Chebyshev polynomial. And for omega to be the Chebyshev polynomial, it must have the same roots as the Chebyshev polynomial. Okay, so we must force the issue that the abscissas we use in the interpolation are exactly the roots of the Chebyshev polynomial. So kailangan kong piliin yung mga exabytes to be the roots of the Chebyshev polynomials. So meaning if we have a choice of, or if we can choose freely the exabytes we are going to use in the interpolation, then we can choose them to be the roots of the Chebyshev polynomial so that we get the minimal L infinity norm. And unfortunately, over time na ako, I won't be able to show you an example. I plan to show you an example of using MATLAB to get the interpolating polynomial for using the Chebyshev nodes for these examples in the module. But I guess we'll do that on Thursday na lang. And let's see where we are at on Thursday para ma-plan natin kung anong mangyayari sa Monday. But I guess my hunch is mukhang magdi-discussion uli kayo partly on Tuesday, on Monday's lab. But I think that's fine para hindi naman tayo nagmamadali. So kesa tapusin ko yung module na pahapyaw lang yung discussion. Okay? Any questions?
No questions po right now, sir. Ipaprocess ko po muna.
Masyado bang marami? Masyado bang heavy yung mga discussions natin? Or siguro pag binasa nyo naman yung kung nag-make sense siya ngayong diniscuss ko siya, siguro pwede nyo i-retrace yung processes. So once you're doing it on your own. So yeah, process everything. That's fine. Take time. Let it simmer. And then on Thursday, if you discovered some questions, then you let me know. Okay? That's our deal. So kung may questions kayo, bigay nyo sa akin on Thursday. And on Thursday, I'll start showing, working with MATLAB, how to work out example 3.1, 3.2, and so on. And hopefully makapunta pa tayo sa legend polynomials or legendary polynomials para konti lang yung i-discuss nyo sa lab on Monday. Any other concerns? Wala naman. Sorry, overtime again. But yeah. Let's call it a day. So I hope you will enjoy the rest of your day. Thank you for coming, and let's see each other again on Thursday. Bye, everyone.
Thank you po,
Bye po,
sir.
sir. Thank you po.
Thank you, sir.
And finally, may narinig na rin ako mga reactions.